We'll do one last example here. I'll do it a little bit faster this time because, you know, you can pause and go back. So, the 6 newtons is an x component. This 4 newton vector has an x component this way and a y component this way. So here's x, here's y, this is the 55 degrees. So we're going to split this 4 newtons into its x and y components. So x is equal to 4 newtons times the cosine of 55 degrees. Right? You can set up the cosine ratio. Cosine equals adjacent divided by hypotenuse, and then do the algebra. Feel free to do both steps, but it's always going to end up this way. And so our x component is 2.3 newtons. And in this case, it's toward the west. Then we will do the same thing with y, except it's sine this time, right? And so it's 4 newtons times, that's a terrible bracket, but let's go with it, times the sine of 55 degrees. And then you get 3.3 newtons. And that's to the north. Okay, so now we've got 2 x vectors and 1 y vector. So we have to add up our x vectors to get our total x component. We don't have to do anything to the y vector because there is only one of them. And then we'll continue with the 2 steps that we just did, putting the x and y back together using the Pythagorean theorem, and then figuring out the angle using inverse tan. So if you think that you know how to do it from here, just pause, go ahead, we'll come back. So here we go. I want to add up my x components first. So I had 6 newtons to the east, and I had 2.3 newtons, but that was toward the west. So I'm going to end up subtracting. 6 minus 2.3 gives me 3.7. So this is 3.7 newtons, and that's going to be toward the east. So that's my total x component. My total y component doesn't need to be added together because there is only one of them. And so that's just 3.3 newtons toward the north. So now I have my x component and my y component. Now I'll put them back together using the Pythagorean theorem. So I'm going to draw the this time I'll draw the y component first and then the x component on top of it, just to show that it doesn't matter what order you draw them in, you're going to get the same answer anyway. And so I'm going to do the y component here, which is 3.3. And then from the end of that one, I'm going to draw my x component, 3.7. It's important that you do them tip to tail, that you see this going on here. You cannot draw them tail to tail, so if you drew it like this, instead, with the 2 arrows pointing away from each other, like separating, I don't know how to draw this, separating from each other like that, that's not going to work. You're going to get the wrong answer. What angle do you use then? Because the angle between the 2 vectors is 90 degrees. It's just confusing. Okay, so you need to make sure that you're using the tip to tail method like this. So your resultant is like that, and the angle that we're going for is this one here. You're looking for the angle that is formed at the beginning of your path. Okay, so this was where we started drawing our vectors, and that is going to be our reference point for which direction you're traveling. You're traveling from there. Now, in this case, it's not traveling anywhere. We're talking about force vectors, and so you're not going, but it still works exactly the same way. So let's add up these 2 vectors using the Pythagorean theorem. So our resultant is equal to the square root of 3.3 squared plus 3.7 squared. And so our resultant is 5.0 newtons. Again, I need a direction on that thing because it's a vector. And so this is the angle I'm going for. So I'm going to use the inverse tan of opposite over adjacent. So that's 3.7 over 3.3. And when I do that, I'm going to get the angle I'm looking for, and that angle is 42 degrees. Now, I'm hoping that if you, in that paused section, decided to actually try this whole thing, and if you decided to draw the x component first and then the y component, I'm hoping you didn't erase your work when you saw us doing this, because you're going to find that you got exactly the same answer. Well, I hope that you're going to find that, because you should. It should work totally fine. In my case, it is a northward vector that we're starting with, right there, and we're measuring toward an eastward vector. And so our final answer here is going to be 5 newtons, north, 42 degrees, east. A totally valid answer, if you drew your x component first and then drew your y component, would be 5 newtons. That shouldn't have changed. East, 48 degrees, north. That should work totally fine as well. Okay, both of those actually put the vector in exactly the same place. And so this is our final answer, either this 48 degrees one or the 42 degrees one, but the compass directions have to be in the correct order.